Assalamualaikum warahmatullahi wabarakatuh. We will be presenting our project on pavement performance evaluation focusing on skid resistance, surface texture and drainage characteristics. The project was conducted by 4 people. First is me, ABDUL AZIM bin MUSTAPA KAMAL. Second, we have NURFARAH NATASHA BINTI Muhammad FAIZAL. Third, we have NURUL IZATY binti Muhammad GHAZALI. And lastly, we have SYUHAIDAH binti Abdul Hamid. This project evaluates the pavement properties that influence skid resistance, texture and drainage. All are critical for highway safety and performance. The first test is skid resistance test. It measures the friction in dry and wet condition. Second is sand patch test, is to measure the surface texture. And lastly, the outflow meter is to measure the water discharge efficiency.
Skid resistance is a critical parameter for road safety because it affects how well vehicle tire grip the pavement, especially during braking and in wet conditions. In this section, we will explain how we use the British pendulum tester following ASTM E30322 to evaluate the skid resistance of our pavement surface under dry and wet conditions. Our main objective were to measure skid resistance, compare dry and wet conditions, assess the effect of moisture on frictions, classify the surface based on British pendulum number, and check the consistency of our readings. The equipment used includes the British pendulum tester, a 4S standard rubber slider, the pavement surface, water, a washing bottle, a soft brush and cloth, and data recording sheet. The procedure starts with surface preparations, where the pavement and rubber slider are cleaned to remove dust and debris. Next, the pendulum arm is set at 90 degrees and the pointer is adjusted to 0. A conditioning swing is then performed across the surface, but the reading is not recorded. After that, 2 measurement swings are carried out, and the pointer deflection is recorded to each swings with the pointer reset to 0 between readings. For the wet conditions, the pavement surface and slider are re-wetted between each measurement swings to simulate rainy conditions. A quality check is done to ensure that the reading do not differ more than 3 units indicates reliable results. Finally, the same steps are repeated for both dry and wet conditions to allow direct comparisons. Our test result show an average British pendulum number of 105 in dry conditions and 84.3 in wet conditions. Both values fall into the very high skid resistance classifications, meaning the pavement provide excellent frictions and braking performance even when the surface is wet. The small variations between repeatable readings suggest that the test setup and procedure were consistent, which increases the confidence in the reliability of the data. These results indicate that, at the time of testing, the pavement offered a strong margin of safety for vehicle control across different speeds. However, skid resistance will reduce over time due to traffic polishing, binder bleeding, and surface contaminations. So, regular monitoring using skid resistance and texture tests is essential to maintain road safety through the pavement service life. That concludes the skid resistance part of our project presentations.
So next it will be the sand patch test. There are 2 objectives in this laboratory, which is first is to determine the mean texture depth MTD to quantify the macro texture of the pavement surface by measuring the area covered by a fixed volume sand. Next is to examine the water drainage capability to ensure that the pavement surface provides sufficient texture depth to prevent the water film build up and reduce the risk of hydroplaning. The apparatus that will be used is sand, measuring beaker, ruler, spreader disc with surface covered by rubber, and wooden brush. So the first step for this lab is the spot on the road is selected to be tested, normally in the near side wheel track. The surface of the pavement is cleaned from any sand or small stone by using the wooden brush. Next, 40 ml of sand is poured into the measuring cylinder and poured into the road surface. The sand is spread in a circular direction by using the spreader disc until the sand will evenly spread. Next, we will take the diameter of the sand and it will be recorded. The last step is the step will be repeated at a different location, mostly at the left or right of road pavement. So the data obtained for this lab is 20 centimeter in diameter for the sand that was located at the center of the road. And by using the formula pi d squared h over 4, we will get the MTD, which is 0.0318 centimeter. So for the discussion, the sand patch test results show a mean texture depth MTD of 0.318 mm, indicating a smooth to moderately smooth pavement surface with low macro texture. This surface condition is typical of dense asphalt and provide good riding comfort and low noise. However, it limits the surface water drainage. As a result, skid resistance may be reduced, especially under wet condition and at higher vehicle speeds. So when compared with the JKR standard, the measured MTD is below the 0.5 mm, therefore for acceptable macro structure and does not meet the JKR SPJ recommended average, which is 0.75 mm. Therefore, although the texture may be adequate for low to moderate traffic roads, it is insufficient for high speed or wet condition in Malaysia, indicating a potential of safety concern.
Next test is flow meter. So the objective of this test is to quantify the amount of water discharged using a flow meter by measuring the amount of water collected within a given time interval. Second objective is to address the needs of students to comprehend the fundamental principles behind the water flow measurements and the relevance of accurate water discharge calculations to road drainage systems. So these are the apparatus used in this test. We need the stopwatch, 400 ml of water and the flow meter. To do this test, the flow meter shall be positioned at the selected road locations with the experimental site position on a flat, stable ground. Second, a volume of 400 ml of water is poured into the measuring tank, and then the timing started immediately when the valve was opened to allow the water to start flowing. Next, the stopwatch is stopped when all the water was drained from the measuring tank, and then the discharge is calculated using the recorded volume and time. And lastly, the procedure is repeated at another 2 different locations to obtain consistent and reliable results. This slide shows the rate of flow for a constant volume of 400 mm³ at 3 different locations. Location 1 has the highest flow rate due to the shortest time taken, indicate smoother and more efficient flow. Overall, the results showed as time taken increases, the rate of flow decreases. In this experiment, the flow rate was determined using a constant water volume and the measured drainage time through the flow meter. Location 1 recorded the highest flow rate, while location 3 showed the lowest flow rate. The results indicate an inverse relationship between drainage time and flow rate consistent with a basic hydraulic principles. Variations in flow rates are mainly influenced by surface conditions, where smoother surfaces allow faster drainage, while rough or uneven surfaces increase flow resistance. Minor discrepancies may be caused by experimental and human errors, such as duration time in operating the stopwatch and also the valve control. Thank you.
Before conducting all tests, several safety precautions were taken to ensure a safe working environment. First, all equipment was handled and operated according to the standard testing procedures. Second, we must wear appropriate personal protective equipment, which is PPE, such as safety vests and safety shoes. Third, the test area was also ensured to be free from traffic to avoid any accidents. And lastly, after completing the test, all equipment was cleaned, dried and stored properly for future uses. In conclusion, the pavement performance was evaluated using the 3 main tests, which is the skid resistance test, sand patch test and the outflow meter test. The first one, the skid resistance test, results shows a very high friction values in both dry and wet conditions, indicating an excellent braking performance and road safety. Second, we have the outflow meter test. It confirmed the importance of effective surface drainage and faster discharge improves safety during rainfall. Third, the sand patch test indicate a low macro texture depth, which suggests that the surface may not be suitable for high-speed wet conditions. Overall, the pavement is suitable for low to moderate traffic, but improvements in surface texture are recommended for better performance under heavy rain and high-speed conditions. That concludes our presentation. Thank you for your time. Assalamualaikum warahmatullahi wabarakatuh.